young scientist.
When you develop a methodology, you need to make sure that by doing this you will answer your hypothesis. You need to think about things such as how you will change your independent variable, what will you measure and how will you measure it, that is your dependent variable, what sort of data will be collected, will it be qualitative or quantitative, how will this data be collected, what equipment will you need to do this, how will you control other variables, how will you minimize risk. Okay, it's really important in science that we think about the safety involved. Is there risk in using the equipment? Is there risk in carrying out part of the experiment? And make sure you repeat your experiment multiple times to increase reliability. Whenever you develop an experiment, it's important to think about accuracy, reliability, and validity. Don't mix these three up. This is a common mistake in exams where students will just talk about all three of them collectively as if they are the same thing. But accuracy is about how close a result comes to the true value. And so when we're designing an experiment, this comes to our choice of the measuring apparatus and how fine we can measure those results. Reliability is the degree to which an experiment produces consistent results. And so if we want lots of consistent results, we need to keep making multiple measurements, and so we repeat. And validity is how well an experiment actually tests the hypothesis. Okay, there's no point doing the experiment if you're actually testing something different. Now, a good way to remember this is validity is all about variables. Okay, so they both start with V. And we need to control the variables so that we know that any result we see is as a result of the independent variable, and so we know we have tested the hypothesis. Reliability is about repeatability. They both start with R. And the more times we repeat it, we should see that the results are consistent. Now, just because we repeat it lots doesn't mean it is reliable. We then need to check our data to see if it's consistent. But if we haven't repeated it, we can't check for reliability. And accuracy is reliant on the apparatus when we're looking at our development of our methodology. And they both start with A. And so hopefully you can remember that. So accuracy, apparatus, reliability, repeatability, validity, variables. And I'd suggest that you write those three definitions down in your glossary if you haven't already. Often in science, what we write is actually a procedure, not a method. That is, we use dot points, sometimes numbered, to indicate the steps that we are going to take. Now, this is fine in the planning stages, but when we write up our final report, we need to write a methods as opposed to a procedure. And so the methods of a scientific paper should clearly explain how the experiment was done, and this should include the experimental setup, the data collection, and the data analysis. So it's more than just what you plan to do to set up the experiment. It's got to look at how you collected the data and then what you do with the data after that. The methods should be, unlike a procedure, should be written in paragraph form, no dot points, no steps, should use third person, past tense, just like in the introduction. So we avoid I, we, us, and we make sure that it is in past tense, not what we are going to do, it is about what we have done. Remember, once you've finished writing your methods, to try putting it in Scribo to check it.